So now let's look at some examples related to rational numbers. So I'm going to ask a bunch of questions. So first is 10 over 3 a rational number? Yes or no, and why? Well, remember, to be a rational number, you have to write it as a quotient or as a fraction of integers. If I look, right, 10 and 3, those are both whole numbers, they're integers. So the answer is yes, 10 over 3 is rational since it is the quotient of the integers 10 and 3. All right, so now let's ask something a little bit harder. Is 0.281 a rational number? So it's not written as a fraction, but can I write it as a fraction? And the answer here is yes, I can. 0.281. I can write it as 281, and I have to move it 3 decimal places, so it's over 1,000. Is a quotient of 281 and 1,000. So if you have a terminating decimal here, like 0.281, it will be a rational number. All right, what if I ask, is 7 a rational number? Yes or no, and why? Let's take a second. What do you think? Can I write it as a quotient? And the answer is yes. 7 is a quotient of 7 and 1. 7 is the same thing as 7 divided by 1, so I can write it as a fraction. What about if I ask, is 0 a rational number? Can I write it as a fraction of integers? 0, it's 0 over 1. So yes, 0 is a quotient of 0 and 1. So this works with any integer. We just did 7 and 0, but any integer, you can turn it into a fraction just by dividing by 1. Is 2 over 0 a rational number? Yes or no, and why? So the answer here is no. And if you want to know why, look back at the definition of rational. We said that the denominator cannot be 0. Here the denominator is 0, so it's not a rational number. So then I'll ask, if it's not rational, is 2 over 0 a irrational number? So what do you think? Yes or no, and why? So the answer is no. This is not an irrational number. Why? Well, remember, secretly kind of hidden there, it's not so secret, but maybe a little bit hidden in the definition, every irrational number is a real number. And 2 over 0 is not a real number. It's undefined. All right, so let's look at a couple more and then we'll be done with some of these examples. Let's go back to decimals. And now I'm going to take a different kind of decimal. Let's do a repeating decimal. 1, 2, 1, 2, 1, 2. So it repeats forever, 1, 2. Is that a rational number? Can you write it as a fraction? Yes or no, and why? Well, the answer here is yes, it is a rational number, and let's justify it. So I'm going to call x this repeating decimal. And so then what I'm going to do is, because there are 2 digits here that are repeating, I'm going to multiply both sides by 100. Just enough to move those first 2 repeating decimals in front of the decimal place. And then what you're going to do is you're going to subtract these 2 equations together. So you're going to take 100x minus, take the second one minus the first one, and if you subtract these 2, you're going to get 12. Because the decimal parts match up, so when you subtract, the decimal parts will cancel. So now you're going to get 99x equals 12. So x is 12 over 99. So you've written x as a ratio or a quotient of 2 non-zero integers. So that means it is a rational number. And it turns out that every repeating decimal is a rational number. You can write it as a fraction. All right, let's look at the last one here. If m and n are integers and neither m nor n is 0, is m plus n divided by m times n a rational number? So the first thing you need to ask yourself is, well, I've already got my fraction given to me, but is the numerator an integer? Is the denominator an integer? Are they guaranteed to be whole numbers? And the answer is yes. So since m and n are integers, so are the sum, m plus n, and the product. Now the only other condition is we need to make sure the denominator is not 0. So why is the denominator not 0? Well, we were told that m is not 0, n is not 0. So a product of 2 numbers that's not 0 is not 0. M times n is not 0 by what's called the 0 product property. So let me state what the 0 product property is. It says exactly what I just mentioned. If neither of 2 real numbers is 0, then their product is also not 0. So we have a fraction where the numerator and denominator are integers. The denominator is not 0. So I can say, my conclusion, I can say, so yes, m plus n over m times n is a rational number.